talk about angles and the unit circle. This will start our notes for section 5.1. So first, let's talk about angles as they're drawn in standard position. So angles roughly are measuring the amount of rotation of something. So in standard position, there's kind of some specific guidelines that we follow so that we can show an angle in the XY plane in a very consistent manner. So first thing about standard position, if we're in the XY plane showing an angle, is where all of the angles start, which is going to be right here, the positive x-axis. And we're assuming that everything is kind of pinned to the origin and rotating around the origin. So that little red line can kind of come up or come down and spin around. So this is always start. The fancy thing to call it is the initial side of the rotation. And then a positive angle. So if we say like, oh, rotate 30, that's going to be counterclockwise, meaning it rotates up this way. So this is a positive angle. And then any negative angle would rotate down in the other direction. So if we do negative 30, that would be down this way. So when we draw an angle, kind of where it lands, typically we're just drawing an angle kind of like this, right? So like, okay, there it is in standard position. That's where it lands. And then what we're actually showing, this like landing spot, this is called side of the angle. So we'll use that phrase occasionally, and that's just what we mean is like that actual little line is the terminal side. Okay, so let's also talk about what the unit circle means. And for a moment, this is fully disconnected from what I was just talking about showing angles. Okay, so the unit circle is just one special circle. Its formula is x squared plus y squared equals 1. So if you graph it, it looks like this right here in red. So it's a circle centered at the origin with a radius of 1. Anytime we use the word unit in math, it typically refers to like the size 1 option of whatever you're doing. So what you're actually graphing here is all of the xy points, where when you plug in the x and y of the point, it perfectly satisfies this equation. Okay, so the reason we care about the unit circle is what we see next here. So when we locate an angle, we'll show where its terminal side hits the unit circle. So the way that I drew this first example here is not really how we're going to show them because we're going straight to the trigonometry part of all of this. So what we'll see instead is kind of starting to be modeled here, where if I say, okay, locate 30 degrees in standard position, we're not only going to show 30 degrees counterclockwise from the positive axis, but we're also going to kind of show where it's hitting the unit circle. So in all of our pictures, there's going to be this circle in the background. For now, it seems unnecessary just to kind of do this, but with a circle behind it. But this is the connection that eventually, when we come back together, this is the connection that's going to be made to the trigonometry part where sine and cosine have something to do with that circle. So for now, we're just kind of going with it. Okay, so first we want to talk about degrees. Typically, these are the most intuitive way to measure an angle and the one you've probably seen in your life before. So if we're starting at the positive x-axis here, the angle 0 degrees is right there, right? So if you don't rotate at all, you're landing right here on the edge of the unit circle. And then, of course, one full rotation all the way around the circle is going to be 360 degrees. So I'm going to label this two different ways, 0 and 360. So 360 has the same terminal side, even though it's a full loop around instead of not moving at all. Same terminal side. All right. So there's nothing particularly magical about degrees and like what they mean. All it is just chopping this circle up into 360 exactly equal little pizza slices all the way around. The one pizza slice is 1 degree. All right, there's going to be in total 16 locations around this circle that we're supposed to be familiar with, and everything else is a little bit less precise. All right, so if a full rotation is 360, then that means half a rotation is half of 360. So that would be 180 degrees, brings us right over here to this location. Half of that would be 90 degrees, which is up here, right? So 90-degree rotation lands you right here. And then we can kind of use this 90-degree step to label this fourth major location here, right? So this way is 90, plus another 90 is 180. 180 plus another 90 gives us 270 degrees. And then if you add another 90 to it, that brings you to that 360. Okay, so we'll do something similar with these halfway markers through each of the quadrants. So if you remember from last semester, top right is the first quadrant, top left is the second quadrant, and then third, and then fourth down here. So halfway through the first quadrant is halfway to 90 degrees. Half of 90 is 45. So what I'm going to do to go all the way around the circle, labeling these missing tick marks now, is just adding 45 over and over again. So 45 plus another 45 brings me to 90. 90 plus another 45 is 135. Plus another 45 brings you right to 180. 180 plus 45 is 225. Plus another is 270. And then finally, 270 plus 45 puts us at 315. And the last 45 degrees brings you back to 360. All right, so in terms of locating one of these angles, it already seems like a lot to memorize, but the way that I'm labeling them is actually how I find them as well. So for example, if I was asked to locate 225 degrees, I may not have this spot memorized in my head, but I would think, okay, this is plus 145 plus 245, and just keep adding and moving around the circle until I hit 225. So I say, oh, okay, it must be right here on this step of that count. All right, there's two more angles in each of these four quadrants that I'm going to label, and we're just going to kind of step around the circle in a different step size. And I'm going to switch colors to make it a little easier to read. All right, so what we'll do, instead of taking this first quadrant and cutting it perfectly in half at the 45, what we'll do instead is cut this quadrant into thirds. Okay, so 1/3 is right about here, the next third here. So these cut that first quadrant, at least it's supposed to be, perfectly into 3 even pizza slices. So this is actually just skipping the 45-degree marker altogether. All right, so this location right here would be 1/3 of the way to 90. So this will be 90 divided by 3, that's 30 degrees. So that 30 degrees is now my step size. I'm just going to add 30 over and over and over again until I land back at 360. So 30 plus another 30 puts me at 60. Plus another 30, we land right at 90. 90 plus 30 is 120. Plus another is 150, plus another puts me right at this 180 that's already labeled. Mark my thirds. 180 plus 30 is 210. 210 plus 30 is 240. And then plus another, we land right at the 270 that's already marked. 270 plus 30 is 300. Plus another is 330. And then finally, after that, we land back at 360. And again, I don't actually have all of these numbers memorized. If you ask me to locate, let's say 210 degrees, I may not automatically jump right to this location here. What I would do is say, all right, well, let me count out my 30s because I know 210 is not going to be one of the 45s. I'll go 30, 60, 90, right? And just kind of keep going until I say 210. I say, okay, so it must be right here. All right, so these 16 locations are what we call the special angles. These are the 16 locations where we're going to be responsible for knowing all the trig information without using a calculator. So if you ever have an angle that doesn't land on one of these 16 locations, right, it's just, 2 degrees or something, it's still here, but we're not expected to have it memorized. That's something you would bust out a calculator for. All right, so the very last thing we'll talk about in this video is I'm going to take this same circle, just pretend this circle came out round. I'm going to take the exact same circle, the same 16 special locations around the circle, and then label them in a different unit called radians. Radians can be really frustrating at first because they're less intuitive than the degree markers, but they're more important in calculus for reasons that we'll encounter fairly soon. All right, so I'm going to kind of repeat the process here with one starter piece of information. Okay, so the radian measurement of an angle is exactly the length of the chunk of unit circle it kind of intercepts, right? So at this point right here, the radian measure of that angle is just whatever the length of that chunk of unit circle is. So we still have the same starting position. So this is 0 radians. And then one full loop around, we would have called 360 degrees. And now we're going to call it the circumference of the circle, which is 2 pi r, 2 pi times 1, because the unit circle's radius is 1. So this starting position is 0 radians, or also one loop around 2 pi radians. Typically, when radians is the unit measure, we actually don't write the units at all. So see how this has like no symbol with it, whereas this had the little degree symbol. So when there's no units there, we're just going to assume that it's radians. That's the way I'll mark them all the way around here. Okay, so let's fill in top, bottom, left, right first, just like we did before. If one full rotation is 2 pi radians, then a half a rotation is 2 pi over 2, which is just pi. So pi is this position right here. Half of that, which would have been 90 degrees, is now just half of this pi. We'll call that pi over 2. And now we can kind of jump around in a step the size that big. 1 pi over 2, 2 pi over 2. That makes this 3 pi over 2. And then finally, 4 pi over 2 is the 2 pi we already have labeled. All right, so these angles are all going to be some sort of fraction with a pi in them, but they're all just kind of ratios of pi, so don't let it scare you. Okay, so this marker right here, which originally we were calling 45 degrees, now we're going to say, oh, well, that's halfway to pi over 2. So it's pi over 2 over 2, which is pi over 4. So this angle right here is pi over 4. And that's going to be my step size all the way around. And I'm going to count it out like we did before. So this is 1 pi over 4. 2 pi over 4 is already here. 3 pi over 4. 4 pi over 4 is already here, simplified. That makes this next one 5 pi over 4. 6 pi over 4 is already here, simplified, and then 7 pi over 4. And then finally, 8 pi over 4 is the 2 pi that's already labeled. So again, if I was asked to locate 7 pi over 4, I may not have it memorized in my head that it's halfway through this fourth quadrant, but I could count out 1, 2, 3, 4, 5, 6, 7 pi's over 4 and kind of get myself to that spot. Okay, so now we'll do the equivalent of that 30-degree step size all the way around and we'll be done. All right, so again, we're going to imagine cutting that first quadrant into 3 equal pizza slices. So this location right here is 1/3 of the way to pi over 2, which is going to be pi over 2 times 1/3, which is pi over 6. And here is pi over 6. So now I'm going to just jump around 1 pi over 6, 2 pi over 6, and so on. The trick with this one, though, is that a lot of these are going to simplify as we go. And I'll try to show both here. So here we have 1 pi over 6. This next one is 2 pi over 6, which will be pi over 3 when we simplify it. 3 pi over 6 is here, already simplified. This is 4 pi over 6, so that's 2 pi over 3 simplified. 5 pi over 6 doesn't simplify. 6 pi over 6 does. Then we have 7 pi over 6. This spot right here is 8 pi over 6, which will simplify to 4 pi over 3. That was 8. So this is 9 pi over 6. That checks out. 10 pi over 6, again, simplifies. 11 pi over 6 doesn't. And then finally, 12 pi over 6 is the 2 pi that we already had labeled. So in this class, as annoying as they are, we're going to focus on radians, again, because of the calculus stuff that we have coming. So the way we're going to use these is, for example, if I say locate, let's say 7 pi over 6. I'm going to draw a little unit circle, and I know I have 3 tick marks in each quadrant. So now 7 pi over 6s. So now I'm going to count out the pi over 6 chunks. So I'm just kind of skipping those halfway markers. 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7. So 7 pi over 6 is this angle in the third quadrant. We'll practice more of this in class together.